So in this video, we're going to look at an application problem involving radar detection, and we're going to apply the law of sines to solve it. So here's the problem. It says, notify environmentalists of the presence of big game. Motion detectors are installed 200 yards from a watering hole. A pride of lions has just visited the hole and is leaving the area at the 29-degree angle shown. If the maximum range of the motion detector is 90 yards, will the pride be detected? So we're going to ignore part B for the moment. So here's the two primary possibilities. We have a motion detector, which I've represented with an M, a watering hole that I've represented with a W, and we have a pride of lions, which I've represented with a P. And what we're told is that the motion detector is installed a distance of 200 yards from the watering hole. And our detector, which is right here, has a range of 90 yards. So it can detect anything within a circle of radius 90. And we're also told that the lion pride leaves the watering hole at an angle of 29 degrees. So one possibility is that the range of the motion detector isn't great enough to intersect with the projected trajectory of the lion pride. And if the range isn't large enough, then we don't detect the lion pride. However, the other possibility is that the motion detector, which is installed 200 yards from the watering hole, if it has this range of 90 yards that it can detect, the range of 90 yards may in fact be large enough to intersect the path that the pride of lions is taking. And if that's the case, we'll detect them. The pride would be moving at their 29-degree angle away from the watering hole, and we would first detect them when they got into detector range within the 90 yards of the detector, and then they would stay in range for some length of time before they exited range at the 90-yard mark again. And so what we want to notice, when we're either going to detect them or we're not going to detect them, regardless, we're in an angle side situation. This is an angle side situation. Angle side. Hey, two possible triangles that we can get out of this. 90 yards. Here's a triangle representing where they come into detector range, and here's a larger triangle representing where they exit detector range. So in an angle side situation, we've already seen there can be no solutions. There can be two solutions. There can be one solution, depending on the geometry of the problem. So in part A, it's actually on purpose been selected to be this situation where there isn't a solution because the detector range isn't large enough to pick up the lion pride. And what we want to do for part A is notice what happens mathematically when we have a no solution type of situation. So my first suggestion is that whether you think there's a solution or not, and in this case I know that there isn't because it's been contrived so that there won't be one, but regardless, draw it as if you had a solution. Draw in your features. Here's the motion detector, the watering hole. Here's where the pride of lions comes into range. Here is where it exits the range, and label in your distances. Here's the 200 yards between the motion detector and the watering hole. Label in those distances, there's our 90 yards, as if there were a solution. And the idea is, if we are going to detect the pride of lions, if we try to solve this triangle, like we did in the mechanical using the law of sines videos, then the triangle should have a solution. If we don't detect the pride of lions, if we're in this situation right here and we try to solve for these two triangles, what we'll get is no solution coming out of it. So label it as if there is a solution, and then think about what it is that you're trying to find. Well, if there is a solution, there's going to be an angle associated with the motion detector. There is going to be an angle associated with the watering hole. There's going to be an angle. In fact, if there's a solution, there will be two angles associated with the Pride of Lions. One when they come into range, one when they exit range. And then just like we did in the mechanical videos, just catalog what you know. The watering hole angle is the 29-degree angle at which the lion pride leaves. So we know this angle is 29 degrees. And then we would need to solve for little m, the side opposite big M. So the side opposite big M, I don't know this. This is the distance between the watering hole and the Pride of Lions, the distance from the, or M could be this larger obtuse angle, the distance from the watering hole to the Pride of Lions as we exit. So we don't know little m, but we do know little w. Little w is the side opposite angle w. So the side or sides opposite or angle of w are the 90-yard sides, representing the detection range of the motion detector. And little p will be the side that's opposite the Pride of Lions, which is going to be the 200 yards. It's either going to be, hey, there's 200 yards there, or opposite the Pride of Lions, there's 200 yards. And what we need to do is determine whether this triangle has a solution. This or these triangles have a solution. So we just try to solve them. So you start off right here and you say, hey, I have 1, 2, 3 pieces of information. The law of sines will let me get the fourth piece of information that I don't know. And that's going to be the angle P, the pride angle. So I'm going to try to solve for it. So I'm going to say, hey, P sine of P over the side opposite P, which is the 200 yards, needs to equal the sine of 29 degrees over the side opposite 29 degrees. So it's going to be 90. And then we multiply both sides by 200 to get the 200 out of the denominator position. So 200 divided by 200 is 1. 1 times sine P is P. And this is going to equal 20 over 9. And I can approximate this. I can get a super good approximation without even going to my calculator. The sine of 29 degrees is almost the sine of 30 degrees. And the sine of 30 degrees is a half. In fact, the sine of 29 degrees is just a smidge smaller than a half. So this is going to be approximately equal to 10/9. And the key here we want to notice that this number is bigger than 1. And we know that the sine of an angle has to live on the interval from -1 to 1. The biggest number the sine can give us is a 1, and the smallest is a -1. So if we get the sine equal to a number bigger than 1, we know there's no solution. And we could double check this by plugging this right here right into the calculator and getting a nice decimal approximation of it. In fact, I could do that right now. I could just say, hey, what's the sine? Put on a cheater reader so I can read. What's the sine of 29 degrees times 10, and we could divide it by 9, and sine of 20 degrees. Oh my gosh. Sine of, let's try this again. Sine of 29 degrees. I typed the number in wrong. Sine of 29 degrees times 20 times the 20 sitting there, and then divided by 9. That's going to equal 1.07. So if I approximate this, I get 1.0, actually 8. The key is that number's bigger than 1. And because it's bigger than 1, and the biggest number the sine function can give me is a 1, if I put this into my calculator, if I do the sine inverse of both sides, if I do the sine inverse of both sides to get the p out. So if I do the sine inverse of, and then in here I have that sine of 29 degrees times 20 over 9, the calculator is going to give me a domain error message on it, or it's going to say, hey, you can't put this number into the sine inverse function. So that's how you can tell. That's how you can tell that you're not going to get a solution. You're going to, if you get a number here that is outside the range of the sine function, then you know you were trying to solve a triangle that didn't exist because there was no intersection between the motion detector radius and the path at which the lines had exited. So part B, the purpose of part B is to actually give us one that has a solution. So it says if the maximum range of the motion detector is 120 yards. So we're changing the radius on this circle. We're making it larger, giving ourselves a larger range. We still have the motion detector, the watering hole. The Pride of Alliance come into the detector range and exit the detector range. So we get all the same labels. We get the 200 yards between the watering hole and the motion detector, but now this radius is 120 instead of 90, and we're asked to find the distance. Over what distance will the Pride be in range. So the distance over which the Pride is in range is this distance right here. And so what we want to notice is that to calculate this distance right here, the distance through which will be in range, I would need to know the distance here from the watering hole to where the Pride exits range, and I would need to know the distance from the watering hole to when the Pride enters detection range, and I would need to take this larger distance minus the smaller distance to get the distance that the Pride of Lion walks in yards while they are in range. So what we're going to need to do is solve both triangles. So again, start off by in this case we're going to assume that there are two solutions to our angle side problem. This is my angle of 29 degrees. I have angle side. Assume that we have the two solution situation. Label everything in your picture. Hey, I have a motion detector angle, which I don't know. I have a watering hole angle, which I do know. The lions leave at the 29 degree angle and follow this path. I have an angle that the Pride makes with the motion detector and the watering hole. I have this angle here. We'll call that the Pride angle. And then we're going to have the sides that are opposite them. So we're going to have little m, little w, little p, and we're told two of those sides. So opposite the Pride angle is the 200 yards, and opposite the watering hole angle is the 120 yards. So we know those two numbers. We don't know this one, the side opposite m, which is either going to be, the side opposite m is going to be, here's my m angle. It's either going to be this, or the other m angle is going to be this on the bigger triangle. And so the side opposite that is going to be this distance here. So the side opposite m, the angle m, the two sides that we're going to get are going to be the two distances that we need. So again, we're going to need to solve both triangles. So our m angle, our w, our p, our little m, our little w, is going to be an approximation. And our p, this is equal to 200, and this is equal to 120. So we go ahead and solve the triangle. So we'll start off by finding this angle right here, these two angles, because I know 1, 2, 3 pieces of information. I can use them to find the fourth. So we just start chugging through it. We know that the sine of angle P, which is the Pride angle, there's two of them. There's an obtuse and an acute Pride angle. So the sine of P over little p needs to equal the sine of 29 degrees over the side opposite 29 degrees is 120 yards. So we put that in. And then we multiply both sides by 200 to get the sine of P by itself. And then we take the sine inverse of both sides, which digs the P out. So we get the sine inverse of, We have 200 over 12. The zeros are going to go away for us, and 4 goes into 25 times 4 goes into 12 3 times. So we get 5/3 times the sine of 29 degrees. And because the sine inverse gives us an angle between negative 90 and 90, and we know these are going to be positive measures, this is going to be an acute angle between 0 and 90 degrees. So it's going to actually be giving me the measure of this pride angle right here. And we know that we also get the supplement of this, and that's going to be the obtuse angle right here. So we get that supplement by doing 180 degrees minus that sine inverse of 5/3 times the sine of the 29 degrees. So we get the angle and its supplement as the two possibilities. So first we approximate this angle, which I hope I did ahead of time. Sine inverse of 5/3 times the sine of 29 degrees. This gave us an angle. I'm going to just do it to the nearest degree. This is 54 degrees to the nearest degree. And this other angle here, we get the supplement. When we calculate the supplement of that, we get 97 degrees. Is that right? Oh, no. We get 205 degrees, roughly. No, that's not right either. Did I not do the calculation? That's just the way life goes. So I'm going to do the supplement calculation. 180. Ooh, I did it on another calculator, I think. That's what I did. 180 minus the sine inverse, that's going to be 126 degrees, which I could have just gotten by doing 180 minus the 54. I don't know why I needed to grab my calculator for that. I've got one triangle on one calculator, the other triangle on the other one. So we get 126 degrees right here. And we need to know M. We need to know the length of the sides opposite angle M. So I've got to get the angle here. So that's going to be pretty straightforward. We just take M equals, it's going to be 180 degrees minus the 29 degree angle plus the 54 degree angle. And when we do that calculation, we're going to get a 97 degree angle. Let me make sure, yeah, those numbers are right. 97 degree angle here. And when we do this angle, we're going to get M is 180 degrees, the sum of the angles of a triangle minus the 29 degrees plus the 126 degrees, which is going to give us, on the other calculator, a 25 degree angle, 25 degrees. So if we calculate this here, this P is the acute angle. So when we make this calculation, we're going to be calculating the distance from the watering hole to where the pride exits. So we're going to go ahead and do that calculation. I'm going to give myself a little space. So to do this calculation, it's going to be M over sine 97 degrees is going to equal, and I don't want to use anything that I approximated, so we're going to use this is an approximation here, so we want to use the watering hole angle, which isn't the approximation. So it's going to be the 120, the side opposite the 29 degree angle, divided by the sine of the 29 degrees, and then we multiply both sides by the sine of 97 degrees, which will cancel that out of the denominator and leave us with M. And then we want to approximate M. So M is approximately, we plug in 120 times, I didn't already do it because I'm a slacker. We do 120 times the sine of 97 degrees. And then we divide that by the sine of 29 degrees. So divided by sine 29. And I got that typed in super wrong. 120 times the sine of 97 degrees. This is terrible. Divided by the sine of 29 degrees. Hit enter. 200, that's about 246 yards. So I get 246 here. Yards. And then I need to calculate M right here for the smaller 25-degree angle. So we're going to do that calculation. We do M. Let's get this out of the way and give ourselves some room. We're going to go little m over the sine of 25 degrees is equal to, again, this angle here was actually approximated, so we want to use the watering hole angle and the watering hole side length. So it's going to be 120, the side opposite the 29-degree angle, divided by the sine of 29 degrees, and then we multiply both sides by the sine of 25 degrees, which will cancel this out of the denominator, isolating m, and then we're going to approximate m. So m is approximately, did I calculate that ahead of time like a smart person? 100? Nope, I sure did not. So I need to calculate that. It's going to be 120 times the sine of 25 degrees divided by the sine of 29 degrees, and we hit enter, and I'm getting about 105 yards approximately to the nearest yard. So this is about 105 yards. And then, so that's telling me this distance here is the 246, and this distance right here, this is the 105. So the distance they're in range, which is this distance, is going to be the difference between the two numbers. So distance in range is going to be the 246 minus the 105, which is going to equal, what's that look like? 141 yards is the distance through which the Pride is in range of the detector.